Hello and welcome to the Arts During Hours event. This is a lesson in creative coding. My name is John Park and I'm with Harmonic Laboratory here in Eugene. And we're partnering with ABAE to reveal a new way to create artwork. This might be a little bit foreign to some of you if you've never done any computer programming before, but I tried to set this up to make a very simple visual sketch, just to remind people that computer programming doesn't have to be just to make websites or applications that are running on your phone, but you can make art and visual creative outcomes with code. So let's go ahead and jump right in and see what type of experimentation we can do together. I'm going to be providing all of you with the link to a website, and you can do this editing right in a web browser, preferably on a computer, laptop, or desktop. And the idea here is that I'm going to be providing everyone with this kind of structure. Now, what we have here is a short program. It's roughly 55 lines of code. And don't worry, you're not going to have to write all this code yourself. I'm providing you with a starting point, and the goal of this whole lesson is for you to see how you can make very small changes in a set of instructions, and therefore see many different types of results and reactions. So once you open up this link and you see this website just like this, the first thing I'd like you to do is to click on this button that says auto refresh. Okay, click that on. Now what that means is every time you make a change to the code, you will see the result right away. And the second thing I'd like you to do is to hit the play button. All right, so when I hit the play button here, what we're seeing is the sort of starter basic code that I've set up for all of you. Okay, now if you're wondering what are we looking at right now, if you look closely, these are all a series of ellipses, right? An ellipse would be a two-dimensional shape that's like a circle that got stretched out. And so we're looking at a sequence of ellipses. So if you look at just one of these kind of tails, like an up and down tail of a cat, if you will, you can tell that they are overlapping circles and their colors are gradually fading and changing from one to the one above it to the one above it. Now, um, I certainly could have given you all code where this is just they were all vertically stacked like a tower, but it just wouldn't visually look as exciting. So I wanted to give you a little bit of a starting point just to see that we have some variation. Not only is there sort of one copy of these stacks of circles, but there are three copies. Okay. Now, all of that code that's making this happen is taking place in this web browser here. And every one of these lines, this is like a series of instructions. You've probably heard of algorithms before and how algorithms are starting to change the way we work in the world with, finances and with advertising and a lot of other reasons. But this is a very simple version of an algorithm. And the main thing I want to kind of have you all try to get into right away is just to see that there are some variables that I've set up, some numbers that I've set up for you that you can change, and the result will be a very different type of sketch. So, for example, if you look closely in your web browser, you probably see that there are these number lines to the left. This just tells you what number of code we're looking at, and I can reference these numbers like line number 10 right here, and then you'll be able to look up and see, all right, that's what John's referencing. Um, so all of the lines of code between lines 10 and 20, essentially, are all things that I've set up for you to easily make changes to. And the only thing you need to do is select the number and change it. So where it says number equals 35 in line 10, if I were to change that to 12, okay, and then I just wait a moment, then the program will update the change that you've made and it will show you a different visual. Instead of each tail having 35 copies of ellipses, now there are only 12. Or if you were to change the 12 to 100, okay, now we have a whole lot of them, okay, 100 circles or ellipses per vertical line. Um, and you can make those same types of changes in any of these from essentially lines 10 through 19. I'm just going to describe these, sort of how this could work, and then really, there is no goal of this other than for you to experiment and just to feel, just to kind of understand that making a small change in computer programming can give you a very immediate, visual, and just kind of exciting, sometimes unknown result. So, some of the other numbers just to play with here. And again, if I'll tell you where things can kind of go wrong a little bit if you try them, but the circle size, right? This is how large they are. Currently, I have it set to 80, but if I were to change that to 30, then, oh, sorry, 300, they get giant, or 30, they become quite small. Okay, so that's just affecting the scale of each one of them, the size of each circle. There's this number that says grow. Okay, this affects how fast the thing is shaking from side to side. So for all of these, I've left these little notes for you for an appropriate number range. So for the grow one line in line 12, you could change where it says 0.01 to anything from 0.001, which will make it 10 times slower, to maybe all the way up to 0.05, which will make it very fast, like that. Okay, and you can do whatever feels right, right? Whatever looks good to you. That's the same case for all of these. This thing called wobble, right? If I were to change that number from 40 to say 80 and just wait a moment, now there's going to be more sort of organic variation from one to the next. And you're welcome to break my rules. I have a suggested range, but I'll break my own rule. I say try a number from 0 to 100. Well, let's be rebels and say 380 to see what happens, right? Some very peculiar unexpected results. The differentiation from one circle to the next is much greater now, and it looks a little bit more organic. It's kind of interesting. So, um, this sketch is set up to be a whole series uh, of different numbers or variables that in combination will change the overall look of the whole sketch. So I have no idea, how many total changes you're going to make. I've got what, 8, 9 lines of code that you can change here yourself. And if you find a result that you really love, like, wow, that's a bit dramatic. If you find something that you really love and you tell yourself, "Wow, I really want to be able to save this somehow, to have a keepsake from this process," I just wanted to let you know that if you click anywhere inside of the sketch, the visual side, what's currently the green background, if you were just to click there once, just with your mouse, and then hit the S key, this will automatically pull up a way to save your sketch, and it's just going to save it as a JPEG or as just an image file. So I that this window pops up. It says, where do you want to save it? So I'm just going to save this sketch to the desktop because I just clicked on the sketch and hit the S key. And then when I hit the save button, now I have a copy of that image just saved out from that one moment when you hit the S key. If I want to pull that up, okay, I can look at it. Hey, look, there's essentially a screenshot of my sketch or of your combination that you found. So let's see. I know we don't have a lot of time with this, and you're welcome, of course, to experiment and play with this as much as you want. Again, with all roughly 8 of these combinations, you will come up with something that I'm sure I can't even imagine, right? Um, there are just a couple little more interesting things I wanted to show you here. In line 17, one of these variables, what's called a variable, instead of changing a number like I've suggested for all the other ones, this one says set it to true or false. It's set to true by default. What this is doing is it's showing the background. Essentially, every time a new picture draws, it's creating a new background image, which is cleaning the slate to draw the next series of circles as they move around. But if you set this value from true to false, and I'll go ahead and type in false, now look what happens. It's not cleaning the slate from where the last previous frames were. It's almost like a rubber stamp that's drawing over and over and over itself, or someone who's using a series of pens drawing on a piece of paper and just moving them and sliding them around left and right. This has a very different look. It's one small change that has a very large outcome. So just want to point that one out there. And then the final one that you might want to play with at line 18 is where it says let back color. Okay, so what this is there's a there are three different numbers that you can change. And in a lot of computer programming, you can select a color based on how much of a color has, like how much red, and then how much green, and how much blue. So for each of these three numbers, this one, this one, and this one, you can choose a number between 0 and 255. The first number is how much red is in the background. If you put 0, there would be no red in the background. If you put 255, there would be a lot of red in the background. But then that amount of red will be combined with a different amount of green and a different amount of blue. So if all of these numbers are very small, then our color becomes closer to black. It becomes darker. Okay, and you might be able to find a color you really like. If these numbers are very high, up 255 is the max, then we will start to get very bright background, something like that. Okay, and then if you happen to like colors that are skew more towards, let's say, turquoise. Okay, so I think turquoise has a lot of green and blue, but not very much red in it. So I could essentially bring the amount of red, or that first number, to be low, let's say 20. And the amount of green could be, yeah, green could be pretty high, let's say 200. And then the amount of blue, maybe I'll pull this down to 175. Okay, and so there are different ways to essentially achieve any color that your eyeball can see through a combination of so much red, so much green, so much blue. Okay, so now if you're brand new to this kind of idea of coding and this is all foreign to you and you're nervous about messing something up, don't worry. You're just essentially changing text and instructions. Nothing will physically break, nothing will explode if you put in the wrong thing. The worst thing that can happen is you make a change and your code will stop running. Okay, so for example, one thing that can very commonly happen is if you forget to end a line, like line 10 here, with a semicolon is coding's way of saying that operation is done. But if I were to accidentally delete that line, it would get confused and sometimes the code just wouldn't run. So every line really should end with that semicolon. So that's one thing that can happen. Um, there's some other ones that you might misspell, or you might kind of remove equal sign or something, and then things will break. Now the program comes to a halt. If that ever happens, you can just start all over again if you want, or you can hit Control Z or Command Z on a Mac, which will undo your last operation. Um, the main goal isn't to kind of try and achieve a specific visual, but it's more just to see what happens when you know, carefully but playfully make changes and see what combinations you can come up with. Okay, um, so one last reminder, every one of these numbers between lines 10 and 19, you can change any one of these numbers. Feel free to try it. As soon as you change it, just wait a moment and your sketch, as long as you've hit that auto fresh button and the play button, you should be good. And then the other thing I wanted to mention, again, if you want to save your sketch, if you find something you really like, and let's see if I can very quickly find something that I'm super happy with. Yes, okay, good. I'll slow it down a little bit. I'll add more wobble, and who knows? Let's say this is really what I want. Okay, to save your sketch to your computer, just to save an image of it that you could hold on to or email to your friends and say, hey, look, I did some coding today. You just have to click once in this visual area, right, where you're seeing the end result. Just click with your mouse and then tap the S key. Tap the S key. This is just a little function which will just save that sketch at that moment in time. And if you just want to know, like, how did that happen, there's an instruction for that at the bottom of the code, towards the bottom there. Um, for those of you who kind of, if this is like too out there, then that's okay. This is just like your 15-minute jump into some things that are possible. If you're excited by this and you're like, wow, how do I do more? How do I learn more? Let me just point you to two places. First of all, this whole field is called creative coding, or sometimes computational aesthetics, or math art is another way to look at it. Um, there are different free online resources to help you learn this, and this is mostly running off of this platform that's called p5js.org. The URL for that is at the essentially the top of your code, p5js.org. You're welcome to go jump in and learn as much as you want. It's a very friendly community of art makers and creative coders who would like to do this type of work. Um, and I should just mention that everything that you're seeing here, um, you're seeing the results of a lot of math. It's actually a lot of trigonometry and division and addition. So, one thing I really love to kind of think about is when a lot of people think about artwork, or a lot of artists self identify with being artistic because they're not analytical. Or I'll hear from a lot of my students at the University of Oregon sometimes say, I chose art because I'm bad at math. And I think creative coding is a perfect way to either uh, dislodge that false dichotomy between being creative and analytical. Or another way to look at it is maybe this is how we should start to think about teaching some math concepts, because some people are scared of math and they don't really see the practical outcome. And this is a very beautiful, fun, visual way to essentially approach things like sine waves and trigonometry and a Cartesian plane and a lot of other concepts that come up in algebra and geometry all the time. So, hopefully, this was exciting and a new experience for all of you, and I really appreciate your time. Thank you so much. Bye bye.